Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Right, in this video, we show you the first chapter of MAT 25, okay, which is matrix algebra. Okay, so we look at the definition of matrices. Okay, so matrix definition of matrix is M and N are positive integers, then M by N, so the symbol is times, but we read as by M by N matrix is a rectangular array of numbers. Right, so the main point is matrix is a rectangular array of numbers. Okay, so the shape is rectangle. Okay, rectangle. Okay, another point is to represent a matrix we use capital letter. Okay, this is an example. Capital letter of A to represent the matrix. Okay, next, the notation for the matrix is either square braces or round braces. So you can choose one braces here. Okay, either square, okay, like this example, or round braces. Okay, round braces is here. Right, then the number in the array are called entries or elements of the matrix. So for example, okay, the lowercase letter here is the elements of matrix A, or the entries of matrix A. Okay, and then the number of M and N. Okay, so what is M? M is the number of row. Okay, M is the number of row, and N is the number of column. So to read the size of matrix, size of order of matrix, we just read the number of row by the number of column. Okay, another term in the matrix is the I at J. So this is the location, the position of the row. Okay, so we use I to mention the row and J to mention the column. Right, for example, so this is the complete notation for matrix. So we use capital letter, then we use the square bracket here. Okay, let's say we have the matrix of 1, 2, 3, 4 as the elements of A. Okay, so the element of A, okay, element okay, you can use any real numbers. Okay, you can use any real numbers. That means all the numbers between negative infinity to positive infinity can be filled in as the elements of matrix A. Right, for this example, I use all the positive integers. Okay, 1, 2, 3, 4. So okay, about the size of matrix, okay, we can count how many row. So this is 1 and 2 rows, 2 rows, and column 1 and 2 column. That means the size of A is 2 by 2. So So this is the size of A. Right. Another one is the position of elements. Okay, position of element, we can use the 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 I and J. Okay, I row and J column. Okay, for example, the element of 1 here, okay, is located at the first row and the first column. That means the position of element 1 is A11. Okay, you can look here, A11, A12. So Ij to represent the position of elements, right? Aij. Okay, next for element 2, so the location of 2, the position of 2 is on the first row and the second columns. That means 2 is A1, 2. Okay, the starting number is row followed by column. Row, then followed by column. Right. Okay, next if we look at the element 3 for matrix A, so 3 is A to 1, second row, first column, and 4 A to 2, since 4 is located at second row and second columns. Right. So this is how we determine the position of element by reading the row and the column of the matrix. Okay, now we look at the example here. So this is the matrix A with element 1, 2, 4, 3, 7, 5. So this is the 2 by 2, 2 by 3 matrix. Okay, the size or the order of A is 2 by 3, since we have 2 rows and 3 columns. Okay, then B. So B is B1, B2 until Bn. We have only one column, one row and n columns. So this is a 1 by n matrix. Okay, one row and n columns. 1 by n matrix. In physics, we name it a row vector with n components. Okay, another one is C. C1, C2 until Cm. Okay, we have m rows and 1 column. So this is m by 1 matrix. The size of C is m by 1 matrix. In physics, we name it a column vector with n components. Okay. So that is for the introduction for the definition of matrix.